Assalamualaikum warahmatullahi wabarakatuh, and hi. So before this we have talked about the green energy systems for HVAC, and now we want to see how to power up those systems by using green energy sources. And then in this lecture we have several green energy sources, which are fuel cell, wind turbine, and also solar photovoltaic, and also biomass. So we're going to see one by one and how it functions. Alright, let's see fuel cell. This is the basic fuel cell structure. There are many types of fuel cell, but we're going to see the basic one. So in this structure we can see that there's positive collection plate, negative collection plate. We have positive electrode, negative electrode, which is anode. We have catalyst and electrolyte in between that connects so that the photon from the negative electrode can pass through to the positive electrode. And we're going to see also how what happened at every electrode that generates electrical energy. Okay, we have basic fuel cell operation. Easy to be understood. The hydrogen comes in to anode or to negative electrode, and at anode the hydrogen will split into electrons and photons, and the photons which creates H plus or ion H plus, hydrogen plus, and the electrons will be forced to go out from the negative from anode, from the negative electrode, and it will go through the circuit to the cathode or positive electrode. That's how the electrical energy is generated, via the transmission of electrons. And what happened to the photons at the anode? The photons H plus will pass through the membrane that you have seen before. We have electrolyte in between, so the photons can pass through the membrane, which have electrolyte, and it goes to the cathode, where the oxygen is supplied, and the H plus combines with the oxygen molecule and will produce water, and water comes out from the cathode. It has this fuel cell, it has high efficiency and it is very clean. Its byproducts are electricity, heat and water. And fuel cells do not have any moving parts, and they operate silently. Fuel cell is also scalable. and it can be compiled on one another to form stacks so that it produce a larger fuel cells for larger systems. It's just that the electricity that is generated from the fuel cell need to be stored in battery, and this will incur high costs for fuel cell despite its high efficiency. So this is what I've told you. We have hydrogen that goes into the anode, and hydrogen as H2, and when it comes to anode with electricity, it will split up into electrons and also H+. The H+ or the photons will pass through the electrolyte, the membrane, and goes to the positive electrode, and the electrons will flows from the anode to the cathode that produces electricity, and as a product at anode, it has high excess heat, and at the positive electrode or cathode, it has water as byproduct. Just to be remembered that at anode hydrogen is supplied, and at cathode oxygen is supplied. Alright, so this is again, you can see the electrons flows from the negative electrode, or known as anode, and goes to the positive electrode, known as cathode, and this produces electricity. There are different types of fuel cell, and these are the common ones. We have proton exchange membrane fuel cell, PEMFC. Then as electrolyte, it uses proton exchange membrane. We have also direct methanol fuel cell, or known as DMFC. We have solid oxide fuel cell, SOFC. We have alkaline fuel cell, AFC, and we also have phosphoric acid fuel cell, PAFC, and all of these are the common fuel cell types with different electrolytes, as you can see here. Right, now we come to the second green fuel source or power source, which is wind turbine. Why does wind turbine, why is actually wind turbines, PV, and also fuel cell is called as green energy source? It is simply because during operation it does not produces something that can pollute the environment. But this doesn't mean that during the production of those devices, for example wind turbine, of course it also uses electricity, but it has nothing to do with the operation. That one, I mean the carbon dioxide generation during the production of wind turbine, all of that is measured via the carbon footprint. Right, let's come back to the wind turbine. So basically, in the four-season country, or in countries where it has different significant different temperatures, in those countries the wind speeds are high. Why? Because wind is created due to the difference of the temperature in the country, because we know that the wind blows from high temperature to the lower temperature. So if we have in a region we have, for example, 40 degrees Celsius, and in another part of the country we have 20 degrees Celsius, then the wind will blow from the 40 degree region to the 20 degree region. And as for Malaysia, since we have mostly the only slightly different temperature between regions, so we do not have this high wind, or we do not have high speed wind in Malaysia. Therefore the wind turbine is not it's not that suitable to be used in Malaysia. Or there are other types of wind turbines. In Malaysia we can use the small wind turbine, the small and vertical wind turbine. The horizontal one that you always seen like this is more suitable in the country with the high speed wind. Alright, so let's see the components in the wind turbine. Of course we have blades, and the form of the blades depends on the wind pattern in the region. We have nose cone as a closure to the blades. We have hub to be connected. We have stator, we have O-ring, we have body of the wind turbine, we have potentiometer, and we have yaw. These are the basic components of a wind turbine. Alright, let's see how the wind can start the wind turbine to spin. Okay, we can see the form of the blade is like an aerodynamic shape. So as wind blows through along the blade, and we know that if the wind goes to the blade where it has how to say, the shape from, if you can see my cursor, so here the wind the wind speed is quite high, but when the shape suddenly reduce, the wind speed will be faster, will be higher, and as the wind speed is higher, it creates the pressure difference. And we know as the winds blows higher, the pressure below the blade will be higher, and the pressure at the upper of the blade is lower, so that creates lift of the blade. So therefore the blade starts to spin. So when one side of the blade has lower pressure and another side of the blade has higher pressure, the wind will start to spin. Right, this graph is the produced power of wind turbine in megawatt vs the wind speed at hub height. Let's measure at the hub height. This graph is the power production of a typical wind turbine. Alright, the speed of a wind turbine must be controlled for efficient power generation and to keep the wind turbine components within design speed and torque limits. And the centrifugal force of the spinning blades increases as the square of rotation speed, which makes the structure sensitive to overspeed. And because of the power of the wind increases as the cube of the wind speed, so the power is meaning to say the power is directly proportional to the cube of the wind speed, or the speed the power of 3. The turbines have to be built to survive much higher wind loads, because sometimes there are gusts of the wind that has unusual speed, and it has higher speed than usual. And wind turbines have ways of reducing torque in high winds. A wind turbine is designed to produce power over a range of wind speed, because the wind speed is variable. It is not constant. We know that. And the cut in speed where the wind turbine starts to spin is around 3 to 4 meter per second for most turbines, and the cut out is at 25 meter per second, meaning to say whenever the speed is higher than 25 meter per second, the wind turbine will brake itself, because it has braking system, or else the wind turbine will be broken, and maybe it will spin through your houses, through the houses under the wind farm. So there are control system in the wind turbine, and there are 3 basic elements, which are sensors to measure process variables, actuators to manipulate energy capture and component loading, and control algorithms to coordinate the actuators based on information gathered by the sensors. Okay, and all wind turbines, it must have maximum wind speed, as I mentioned before, and that is called survival speed, above which there will be damage. And the survival speed of commercial wind turbines is in the range of 40 meter per second to 72 meter per second, and the most common survival speed is 60 meter per second. But there are some wind turbines that have been designed to survive 80 meter per second. So as you can see, this graph, the power will rise as the wind rise. And we know that the power is the power is directly proportional to the cube of the wind speed, and at a certain wind speed it is break. The wind turbine will break so that it will not exceed the survival wind speed. Alright, so these are the examples of wind turbine blade configuration. So we have horizontal axis, as you can see in the green, in green, which is more suitable for the countries which has high temperature difference, meaning to say that it has high wind speed. And another one, the vertical axis, is suitable for countries like Malaysia. So vertical axis, the cut-in speed is not that high. It is suitable for Malaysia that do not have high speed wind. Right, this is direct DC, direct current generator in the wind turbine. So basically in wind turbine we have magnetic field, and as it spins, the magnetic field will be cut by the stator, and it generates electron flow, and therefore electricity is produced. Actually the wind turbine will generate alternate current, but it is then converted into direct current by rectifying the AC into DC. Okay, now you want to see the solar photovoltaic, or known as solar PV. So this is how the electricity from PV is generated. We have light that activates the ions, and we know that in PV we use semiconductor. We have negative type semiconductor and positive type semiconductor ions, and as the light goes is incident on the PV, the ions will be transferred from the positive type semiconductor to the negative type semiconductor, or known as photons. So photons, it flows from positive type semiconductor to negative type semiconductor, and the electrons will flows out into the circuit from negative type semiconductor to the positive type semiconductor via the wire in the circuit, and that generates electricity. And in Malaysia, the normal sun irradiation is about 1000 watts per square meter, and but somehow it is affected by several variables. For example, the angle of the light that hits the PV surface, and the cloudiness or the haziness of the atmosphere. When there is a lot of cloud, then the irradiation is not that much, and it is lower than 1000 watt per square meter. And it is also affected by the height above sea level where the surface is located or where the PV is installed. Alright, so this is the electron current flow in PV, and as I said before, it flows from the negative side of the semiconductor and flows through the circuit to the positive side of the PV, and that creates electricity. Okay, these are the structure, the PV cell structure. We have nowadays we have many types of PV. This is the common one, but now we also have a printed photovoltaic. But this one, what I show you here is not the printed one. It's the conventional photovoltaic. We have cover glass. There are different layers in the photovoltaic cell. We have cover glass, we have anti-reflective coating, we have contact grid, we have negative type silicon, we have positive type silicon, and we have back contact. So if you cut the PV, you can see all the layers. Alright, so I think for the 7th lecture, that's all from me today. So thank you. See you in the next lecture.